Okay.
Now start.
Okay, cool. So let's get into it. If you remember, yesterday we looked at how to create Python pandas from different ways, using dictionary, using list, providing indexes for column, for row, and doing row-wise and column-wise operations, like searching. And now let's go more into it, where we're gonna apply some more row and column wise operations, where we're gonna try to manipulate the data within the row and column. Till now we were like doing, we were not modifying the data frame itself, row level. We are just like doing some operations, but nothing was more of a transformation operations. So let's get into it. So let's start with first creating the data frame. As you can see on the screen, let me share my screen first. Oh, I forgot to share my screen. Okay.
Start presenting first. Start
Oh,
presenting first. Yeah.
okay. I hope you guys can see my screen now.
Yes.
Okay, cool. So yeah, let's get into it. So let's start with creating the data frame first. Wait. Okay.
175% zoom.
Uh, and
Zoom.
okay. Is it not? Is it visible?
Visible, but still little bit small. If you can increase a bit, it will be better.
Mm, will be
Yeah.
200%. Is this
Fine.
okay? Fine. Okay. Uh, okay, so let's get into it. So just as usual, importing pandas and numpy, and then we are creating data frame here. So if you see the syntax here, uh, for the data, we are creating using random. We are creating the numpy array, and as you can see, we are providing the range, and between like five and three is the size, and just we are creating random numbers using numpy. So this is a dimension of our numpy array, which we are providing as a date as a row. And then for the column, we are giving the column names, column 1 2 3. So final answer you can see here, like this is our data frame now. We haven't provided indexes for the rows, so it just create the default ones. And for the column, we have this. So this is a data set that we're gonna keep working going forward. Now, first thing, now if you want to apply some kind of transformation on the data frame, like apply some row level or column level functions where, hey, I have this column, these are all my data. Now apply some function on each of these data and generate some kind of result. So we will use something called df.apply. So let's run this. So here, if you see df.apply, so because we are not providing anything, it's a x is 0 operation, and x is 0, as we told, like it it goes into this direction. When we talk about x is 0, always think about like going below, like doing the operate on each row, on each column. But like so probably row you can say column wise operation, because on each column that make more sense anyways. So np.apply. So what we are trying to do here, when you say np.apply, after apply you pass some kind of function here, and whatever function you apply here, that will take the whole thing as an input, as a list, and produce the output. So most of your aggregation function that you can pass on here, what are the aggregation functions? Your sum, your multiplications, these are all aggregation function, where it takes the whole list of data and try to produce summarized result. Like I give you 10 data and give me average, which is like try to represent those 10 data into this one data. Like what the ages look like in your classroom, you can say probably on an average 12 people, on an average 22 years. So that 22 years try to represent the whole population of your data, like of your 60 students classroom. Like 22 represent, like this is something look like my classroom look like 22-year age uh, average. So basically this is all aggregation functions. Sum is also aggregation functions, like how many money did you make today, like you can say make addition of all the product that you sold today for whatever price, and then add all the payables, and you can say, hey, this is what my total the payment look like. That is also aggregation function, where you try to represent the whole population with that particular one number or some very summarized meaning. Anyways, so you're passing here aggregation function, and because you are saying x is equal to 0, it is kind of column wise operation on each row. So for each of the column, you can see this average value here. If you average all of this is what you get. Now what if you want to do row wise? So you provide x is equal to 1, and it will operate on for each row on all columns. So for 0, it will average all three of these, and uh, likewise. So basically, same thing. You are providing here. You are doing row wise operation by saying that x is equal to 1. Df dot apply. Now this will like so what I can pass on, you can pass on any kind of method which can take iterable as a input. Now what is iterable? We know that list is iterable, anything that you can like iterate on, and that can be passed on as an input. So so here we passed on something that is already available in our numpy. So numpy already has this mean defined within its library, so you can just call np.mean. And if you see here, we are not saying this like when you say, like when you pass on parentheses, this means you are trying to call the method. And when you just want to pass them like an object function as an object, you say np.mean. So when you say np.mean, you are not actually calling the method itself, you are just passing the method. And this method object will be then will be then called internally with the data itself. So just like reminder, like this is not same as np.mean and np.mean parentheses both are not same. One represent the function object itself, and second thing represent you are calling the function that you have already defined. So because you can pass, as you remember, in Python, you can actually pass methods as a parameter, as a variable, as an object. Because of if you remember from your first day, Python is a high level programming language, and it supports high order functions, and high order functions mean one function can take another function as an input. So all this is come together now, that here you are able to in df.apply method, you're passing this another method, and you passing it as an object. Because when you say np.mean, it basically is an object, you're not calling the method itself, it's a function object, you can say that. Okay, so now so you can pass any kind of function object. Basically here you passed np.mean, and now you're passing the lambda, because lambda is also special kind of a function itself. It's also a type of function. So you can pass lambda x mean, x max and mean. If you remember how lambda works, so lambda basically it basically take x as an input, and then like when you say apply lambda on df, so basically it takes x as an input, and then whatever x come as an input, it like this is the output part, what I'm going to return and what my input will look like. So what my input will look like is the whole list. So I'm passing the whole list as in my x. So because the data frame, and when you say data frame dot apply, so data frame dot apply method, this apply method will apply the whole thing column wise, because we are saying that x is equal to 0, because we are not passing x, so x is equal to 0. So I want to apply this column wise. So for each column, I'm going to pass the whole list, like x will be the list here internally, and then on the list it will do x dot max and mean. And now list is it set itself as the mean and max method. So because the numpy, and numpy can do all those things, numpy dot mean, numpy dot max. So because this is numpy array, so on numpy array you can do numpy mean and max, and that's what you are getting here. It's like you can actually see the type, what is the type. So you can say it's a function class, and when I say print np dot mean, it's also like function mean. It's kind of function class. It's a numpy based function, so it looks it's print differently than regular function, but both are function object basically, that you can see here. And this is possible because Python consider all the functions as an object itself, something like of a object of function class itself. It's not something special. So that's why function are first class citizen in Python. Something to like take mind of. Okay, anyways, so we saw that in the df.apply, we can also pass any kind of function, including lambda functions, and that's what to see here. Now we're gonna do something fancy. uh, we're gonna do something called dot map. Now what map function does basically, I have something this lined up for your advanced topic, but let's have a look at here. So what map does basically, map basically do transformation. Transformation means you have a list of elements. On each element you want to apply certain functions, and that function will generate something, another list as an output. So let's say I have 1 2 3 4. So on each 1 2 3 4 I want to apply function, like apply this function on 1, apply this function on 2, apply this function on 3, and every element of the list will apply that function on each element. Like on each element that function will be applied, and whatever output will come out will be stored in another list, and kind of like do the mapping, like one-to-one mapping. If you remember your math, algebra math, and set theory stuff. So in the set theory and group theory, you can say that there is one-to-one mapping. There is a function and domain, and like domain to range mapping. So this is something like that. Uh, uh, you have this input as a list. You apply function, and that function will be applied on each element of the list, and the output of the function will be your like result output, which will be again the list, because you're basically transforming one list to another list. That transformation is defined by the functions. So what is going on here? We have column 1. So first df column 1. So if you remember, this is how we pick the column. So here we are picking the first column, or the column with the name column 1, and then we say dot map. That means we're going to apply certain function on each element of that column. So if you see, let me just print whole thing right out here, so it will be easy to see what it is. So this is your column. What you want to do, you want to apply map. So when you say apply map, then apply this particular function on each of this element, and whatever result come out of whatever the function says as an output will be your like result. So here what we are trying to do, so in lambda we are taking x as an input. So each element will be our x, and then we are throwing x into 100 as an output, x into 100 in this case. That is our output. So basically multiply by 100. So what happened, you see here, this is our x, which will be multiplied by 100, and then we get 59 as an output. And this will apply on each element. So this particular function, lambda function, will be applied on each of this element, and then whatever output comes out will be the output here. So this is how map particular works. It transforms. So this is a transformation operations. This is your column or values will be transformed from one value to another value, and this transformations is defined by this function. What is my input? What is my output? This is my transformations. So this is what basically map does. So this is a transformation operation that you can do on the column. So many things you can do with. There are so many use cases. We'll look into the use case as we go forward. So this was like operation over column wise operation, and map was one of them. Now let's see, we already have data frame, and we want to iterate over data frame. Iterating over data frame, basically we want to like access each of the row and column, and like bring them to the Python side, and try to do something with that. Basically go over or read over each row and do something with that. So how we can do that? So let's for that start our data frame, and let's print how our data frame look like. If you see this fancy thing, so we have pd.data frame, standard data frame, and then we are passing this dictionary thing where it says it's not a list, it's a dictionary, and single dictionary. That means each key will be column, and values will be, it will represent what data it will have. So we have like this total 5 columns, and pd.date range. So this is something in the Panda has this method defined where you can create the range of dates. Basically it will give you a data frame with single column, and you can define different, like what is my start, what is my period. It's going to be 20. That means I'm going to create 20 records here, and then frequency equal to d. So this the it will be day wise frequency. So I want like, every day, like my record will be incremental to the dates, day 1, day 2, day 3, like 1, 2, 3, 4, likewise. You remember this one? We have done this before. NumPy.linear space, where we say start, end, and what will be like how many elements I need, and it will be equally separated space. Data will be generated. So we are say 20. Stop equal to 19 minus 1. That is like 20 minus 1. That is like 19. So 0 to 19, and then equally divided by 20 numbers. So 0 to 19 and divide by 20. So that will be our linear spaced array. Now this is just a random number, so random dot rand and n. So just create 20 random numbers here. Random dot choice. So this is interesting. What you can do is you can define the list and kind of like do provide the 20, and it will like scramble the whole thing and give you 20 elements or whatever you pass n here, like a 20 records where the elements will be randomly chosen by from these three. So if it makes sense, numpy.random.choice, you need to make choice from these three keywords, and then you need to give me like 20 randomly created 20 words, and those words will come from this particular pool. And then to list is just basically like convert the whole thing into a list, because this will give you some kind of iterator. And finally random.normal. So this is more like create the normalized list. So you want to like if you remember how the normal look like. So when we say normal distribution, it's just look like a bell curve, like this, like go up and down. So if you want to create the a normal distribution type data set, so you tell that what is my range look like, and then I think they're like mu and sigma, and then finally you say how many elements you need for that, and to list. So this is basically different way we can generate random numbers or generate random data, and then finally we are using all of them to create this list. So as you can see, the dates, the number incremental, the linearly spaced numbers, randomly picked data, and finally uh, the normal distribution of this with mu and sigma. So this is what we have. Now we want to iterate over them. So what we can do is we can do df.iterate items, and then we use key and value here. So let's see how it works. So key basically is when you say df.item, so basically it goes about the column and then values. So you're first printing key as an A, and then you're printing all the values here. So you can see A0, 1, 2, 3, 4, 5, 6, and up to 20. And then it tells you your name equal to A. So this whole thing is printed as a single unit in your single loop. So when you say print key comma value, so this is what being printed. This is your first key and value, and key will be your column name, and then value will be the values that is inside the column. And same goes for them. So this is the second time in the second iteration, the second column will be picked and its data will be printed, and so forth. So now we know that how we can like print or extract column wise data, and get them into some kind of numpy format. Now let's try to sort data. So sorting basically you have a data frame, and you really want to sort data based on like column, rows, or different ways. Like there are different ways to sort the data, but this is our data set here. We are providing indexing here, and if you see here, we can also provide indexing randomly. As I told you, indexing are basically just name tagging. So you can write whatever you want and it will come up here. So here we are generating random numbers, 2 columns, and then here we are just like giving the random numbers as a tagging here. Like numbers, they are not in sequence here. And now when you say sort by index, it will basically sort your numbers by your index. So if you see 0, this is a 0th record, this is a 0th record. So sort index will sort your records based on index. Your 1th record has 0.9, 0.44. You can see here your one record has 0.9, 0.44. So if you have this kind of like weird looking or whatever you have here, you have some kind of any kind of number that you have here, and if you want to sort, or you just want to sort using your indexes, you can just say df.sort index, and it will keep intact the records itself, so it won't like mess up your data, but it will just order them based on their indices. And then if you want to like do ascending descending, so you can do ascending equal to false, so it will do descending order, so you can also like reverse sort them. So that is also possible using this extra parameter. The default value of ascending would be true, and then when you override say false, then it will do the other way. And same, let's say you want to sort by column name, so I mean some certain column values, so sort values and by equal to column 1, so it will sort the values based on column 1. And then also you can like provide ascending descending again, so that will also work. So basically you can using sort values, you can sort values and sort index. So sort index is sorting based on index, sort value is sorting based on values, and you can use that to sort the data uh, in the column wise and index wise. So this is how you can do all the sorting if you want with your data. Now indexing and selecting data. So again, let's we are creating this huge data set with indexes here. If you see, the indexes are in alphabets. This is something new you might not have seen before, because we've been using numbers always, but you can also do alphabets. And column ABCD, and then we are creating the matrix 8,4, so that you can see here. And now let's get into the index by selecting using index basically. So first df dot loc. So you remember this thing, right? Location will sort using so location will use your index as you define, and iloc will use the internal like 0 1 2 3 4, and loc will use the whatever is already printed here, so your secondary index or your whatever the name tagging that you have used for your records. So if you see the comma here, so basically comma says that this is for the like first like this for the rows and this for the columns. So when you're trying to sort things, you can provide like both. It doesn't has to be, if you just provide one, if you don't provide this part, it will just sort using column, otherwise it sort using row. So what we are trying to do here, so first thing we say that like this column basically means the range is like full range. I'm not limiting or filtering my range here, so you just say colon, so start and end, consider start and end, and then you say a. So because you only say a, this is more like a filtering. So you picked up the a column here. Basically you say that just give me a. Now if you remember, I told you that a b c d doesn't has filtering, I mean sorry, indexing. So that's why when you want to filter using columns, you basically have to like pick each column one by one and tell them that give me this column, that column. You can't do like zeroth column, one column, zeroth one two is it's not actually much used, and I don't know it's internally supported. I haven't seen it being used anywhere. But the idea is when you are working with the columns, you basically go with the column names, and when you are working with the index, you can either go with the row index or either go with the 0 1 2 3 4, this internal indexing basically. So as you can see here, we are not filtering any records. We are keeping all the records, but we are filtering the columns. We are picking the column A. Multiple columns, same thing, A and C. Now here we are for LOC again because it's a name tagging, so you can do ABCD and sorry, so you can basically provide what the name tag that you have provided, like give me all this record with this particular name tag. Same for the row, same for the column, because this is something like name tag. This is not internal indexing of 0 1 2 3 4. And when you have 0 1 2 3 4, then you can use something like this, like give me all the indexes like starting from 0 up till 4. So this is internal indexing, so give you 0 to 4 records basically. So just reiterating again, like with LOC, you can tell that you can provide the list of indexing and in a list of columns, and based on that it will filter the record, filter your data frame, give you like sub data frame out of the data that already been like from the DF itself. And when you don't want to use this indexing, something like you want to use internal, then you use iloc and network here. Now you can also do with the column, but this is not preferred way. I told you, like I haven't seen this being used a lot before. So you normally you normally pick with the column C and D. You don't use this too much, but it's possible. Like it's possible, but not recommended to use. Just not a best practice, I would say. because for row you can have like long range, but column is like you really want to pick the column. You want to know what columns are going into your data. So iloc working on the internal indexes, and uh, and your A, B, C, D, like I mean, when you are using LOC, you are using the name tagging, whatever tag you give to your column and record, and iloc where you are using internal indexing. Okay, so we have seen how we can like pick sub data set, or like we can filter based on row and column and like create the sub data frame from your data frame. Now let's get into actually modifying the data frame. Now, one of the main operation that you will see a lot of data science or data analytics people do is try to see or try to get your data, do some kind of data wrangling and make your data complete. So whenever you're trying to look for data, or like any open source data or any data actually you find, there's always some kind of missing value, and there's always something there which is like missing, and there could be multiple reasons they are missing. Let's say certain things are optional to provide. Let's say some form that you're filling up for your let's say some government record or some kind of welfare scheme, and you don't want to reveal your gender, then there is an option that hey, you have an option not to reveal your gender, and for because they want to give you some kind of privacy or some kind of anonymity to your data. And in multiple cases you can see that because some companies don't want to like say that they discriminate against certain things. So there are multiple reasons why people want to keep it optional. And the thing is, it will be optional, and there will be always some messy data, there will be always something missing. You will never find data which is 100% complete. And when you talk to any data scientist or data analytics, they spend almost 70 to 80% of their time just cleaning data and removing the invalid data, filling up all the missing records and stuff like that. So they spend huge amount of time just getting your data to be complete. And the first thing that they look for is like, what is missing in my data, because I need my data to be complete. Now there are multiple reasons I say that why I need. First thing is, of course, data is messy, but still at the end I want to make my messy data to the cleaner data, because a lot of the functionality that I'm going to apply on my data will ask me for the full data. They will not work if the data is missing. So many machine learning algorithms, when you apply, when you put data into your machine learning algorithm to train your model, they will, a lot of the algorithm will not accept any data set, or they will kind of fail if your data set has missing values. And they say that hey, we need data to be complete, there should not be any missing values, we need that. A lot of time when you are like building a model, you also want to make sure that if certain columns that I have which has like huge number of data are being missed, then why I want to do analytics on the data where the most of data is missing. So let's say I have this data where I'm trying to I have this huge data of employees, and I choose to work on salary field of the data, that hey, I want to work on, like, I want to do the aggregation of the salary. Now let's say employees have not disclosed their salary for, like, let's say out of 100 employees, only 5 people has revealed the salary. So your 95 records out of 100 are empty, because obviously they didn't put the salary there, they didn't provide the salary there. And now if you do any kind of analysis only on 5% of the data, it has no meaning, because like what like you don't know like how you can tell average salary of your company if you have only 5 employees out of 100 are telling the salaries, right? You need the full picture. So a lot of time you want to do this kind of analysis where you want to know that how much data is missing, and there's a huge amount of data is missing. You just want to drop the data out because it doesn't carry much information. If let's say only 3 or 4 data are missing, then hey, so I have this let's say my company has 50 engineers, and 5 engineers have not provided the salaries. But then I can look up, like, let me see all these 5 employees, these 5 employees are software engineer, and I have like other 30 software engineers. So what I can do is I can find the average of those 30 software engineers, and I can assume that these 3 guys whose salaries are missing might be somewhere similar, or might be around the salary of those average of those the other 30 software engineers in my company. So I can like replace those values, and those kind of things I can do when I know that what is missing, and then I can go proceed further. So that's why missing is important. So let's try and see how we can deal with this, how we normally deal with the missing data. So first, we need to create the data set which has missing values. So far, we haven't seen any data which has missing values, but now we're going to create that. Same old, same old. We are creating data set, index, and column, and this is our data frame. So this is our complete data. You don't see anything missing. Now what I'm going to do, I'm going to do something fancy, something funny, and the end result will give me a distorted data frame. So what I'm going to try to do reindexing. Normally when you do reindexing, you can, so right now there are 1, 2, 3, 4, 5. So I should be only providing 5 new indexes here that will override the existing indexing, but I'm just providing extra indexing. So because of that, there'll be like, there'll be gap will be generated here, basically. A, D, and G. So basically, by passing extra indexing, I'm trying to uh, kind of like creating this distort data set with none values. So the idea is now we have some none values in our data set. And in Python pandas, none value look like this, NaN. So uh, so in Python in general, like outside, like Python, basic Python has something called NONE, none, which represent null values, and the Python panda or NumPy version of the those none is nan. So this is what we see here. This is the NumPy nan. This is not Python none. This is basically NumPy nan, np.nan. So this is what we are able to see here. NumPy is the own version of none, basically. So now we have missing value. Now what we're going to do about the missing value? So first, I mean, this is like data set that we can see in single screen, but let's say you have thousands and thousands of rows and you don't know if there is a missing value or not. There might be some missing value. So how do you start with? So first thing, what you do is you can pick any column and just use this method called is null. And what it will do, it will give you this kind of true and false version of your data frame with the same size. Basically, what this tell me is this particular element is null or not. An answer will be, you can see the answer here, true and false, true and false. So this will tell me that if there are trues, then I know that there is a missing value. So as you can see here, this none, and this like mapping to true. So this is like missing value here. That's why it's true. Other values are false. So this is one way, and we'll see how we can use these methods. Now there's another method called not null. It's just inverse of null. So basically, it just tells you not null, simple. And if you see the type is Boolean, so true and false. So what I can do now, I know that there are some none values in my data frame. So to fill the none values, we have a couple of ways. First thing, if I have none values in certain column, I have two options. I can either fill the data or I can drop the data. Like if I see, hey, there's too much, we haven't seen how we can know that how much is missing, but let's say you know that, hey, if there is a missing in this particular column, I'm just going to drop the column because it doesn't make sense to me if data is missing. And second is, hey, I know there is missing, but I can still, I can still fill some values, and I'm good with that. I can do that. So first thing you can do is something called dot fill na and some values. So fill na will just go over the data frame, and wherever it finds nan, it will just replace that nan with the 0. So let's say what you want to do. Let's say you have an age column and there is something missing. You know that how you can do df dot apply, and then you can find you can do the average of particular column, and then what the results comes out. So you can actually extract the average of certain column, and then you can apply, hey, this is the average value for my age. Let me fill all the NA with this particular average value that I have. So this is one of the tactics that people use, that they find average, sum, or some kind of other ways, or find some values that I want to fill this empty, this none with some values. How I can go about that? I can just say 0, I can just say 1, I can put some random string, or I can try to figure out some kind of average, some kind of aggregated value, which try to represent the whole data set, whole population, and use that to replace my none values. So in this case, we're just gonna do the 0, just to represent that there is this method called fill.na, and you can see that all these zeros are being replaced here. Now, there is also different ways to do that. Let's say if you don't want to fill with the zeros, there's one more method called pad. What pad does is basically it do the front filling, front fill. So I'm just using this keyword because it makes sense in a way. So when you say pad, what it will do, it will just look back the previous values, and whatever the previous value is, it will just replace this existing value with the previous value. So if you see here, the B, D, and F, sorry, G, these were null before, and now they have been replaced by the record before them, previous record. So this is the method called pad when you're filling NA. Second is backfill. Of course, makes sense that you are trying to fill the records backward. So your B will not be filled by A, but will be filled by C. Like whatever record below you have, it will try to fill up your values with the record below, basically. So this is what these two methods does. There are multiple methods also, but right now for the purpose that these are the two. And finally, drop NA. So you can basically just drop NA. So delete all the records which has which has none values. So this will just like get rid of all the record which has none. And in some case this makes sense, and if this makes sense for your use case, you can go ahead with that. Now all these things are always use case based, and that's why a lot of data scientists are also called being domain expert. Like as a software engineer who doesn't know what the data represent or what the meaning of the data is, I cannot decide should I keep it or should I delete it, should I replace it with something else, or what value that particular column carries. Let's say this is like a protein genome data, and all these columns are some kind of representation of certain protein gene. I don't know about anything about the protein. Like I cannot decide should I keep this, should I delete this, what this number represent. And someone who has a biotech or biology or something similar kind of experience, so they can understand that, hey, this particular gene represents this value, so this is not so important, I can drop it if there are so many missing value. Hey, this is important, although there's so many missing values, but this is very important, so I have to figure out how to like make the data complete. And those kind of decisions they can make because they are domain expert. And that is why a lot of data scientists, they are also sought after to be a domain expert, and not only software engineers. They also need to understand what those things are, what the business mean of that particular column is, and stuff like that. So just throwing it out there, like all these decisions of keeping or dropping are being made by data scientists because they know what those columns represent. Okay, so this was all about filling up the missing values. Now let's get into something called grouping of the data. Grouping of the data basically means you have this huge data frame, and then you want to like create the sub data frame using some kind of group by making certain groups, and work on those each small data frame for all those group individually. Let's first build the data frame. So this is quite simple. You understand the same old. This is the dictionary, and each key are the column names, and then these are the values. This is like randomized IPL data. So you can see there are teams, there are ranks, and in like this is the year. So in 2014 year, the riders were at the rank 1, and this was the point at the time. Riders were rank 2 in 2015, and devils were second rank in 2014, and like record, like stuff like that. So you can see that there are multiple years, multiple ranks, and multiple teams. And it makes sense that if you can analyze the teams based on year wise or based on team wise, and see that, hey, what my particular team, what each of this team did in every particular consecutive years, or in every consecutive years, what was the performance of the each team look like. So all this kind of analysis, it makes sense if you can make the group wise breakdown. So let's get into it, how we can do that. So this is the data set. I think we understand what data set means and what it looks like. So now first thing, we can create group by teams. So what it basically does is go to your team column and try to find all the unique values in the team and bundle the data which is like which are along with that unique values. So in the team you have this 1 2 3 4 5, basically 5 teams are there, so 5 unique values are there. And based on all these 5 unique column values, it try to pick all the records for those 5. So for the devils, it has some internal representation of what are the records. So this is kind of tell you these are the records for the devil. So like devil has this 1 2, so there are basically 2 values for devils. And then for the kings, there are 1 2 3 records. Now understand this is case sensitive, so there are kings like this and king like this. So this both actually mean the same value, but because they are capital and small, they have been treated differently. So this is one of the reasons why you want to massage your data. You want to like figure out, hey, if there are some missing keys or some missing typos or missing mismatch, and you can like fix them. So that is something normally, when as a task of data engineering or data scientist, do in their data processing pipeline to try to figure out and fix all these kind of issues with the data. Anyways, so because we have issue with the data, we can see total 5 team instead of 4. We're just gonna roll with that because we are just we are working with the groups here basically. So okay, let's get into it now. So this is the group based on only one column. So we are just doing with the one column. You can make a group using two column also. So when you make two column, it try to figure out the unique pair of each of them. So Devils 2014, Devils 2015, this is like unique pair because now year is involved, and likewise, so you can see unique pair. And then you can see that here there are only one record being selected, so it's kind of like this is all the index because we have like single record for each of them. So you are creating like uh, 10 groups here, you are creating 11 teams here, 11 groups here, and each group has only one value. Here you are probably creating 5 groups, but each group have multiple values. And you can see here like riders has 1 2 3 4 records, and kings has 3 record, and this um, wrong key have 1 record, and like there's 1 record which has like wrong thing. So basically you can see that okay, it makes sense because team has more data, and then team and year is basically unique values here, so you can just get the one record in each groups. So now okay, now we have these objects here. We want to work with each of these object independently, so let's start with printing them. So how you can print the group? You can, so first thing you need to create the group. So here we're gonna represent example creating group by year. So group equal to df.group by year, and this will give you some kind of iterator, a generator maybe. And with that generator, you can like go over each of them. And when you say for name comma group, so it will basically this is the result. So this is just print the name, and this is the actual group, which is a small data frame. Now you can see here in 2014 you are getting this 1 2 3 4 record, and then the rank, and you can see that in year 2014 riders were first, devils were second, kings were third, and royals were four. And then second group, which is of year 2015, you can see here year 2015, and you can see the ranking, the next ranking here in 2016 ranking and 2017 ranking. So likewise, like you can group wise, you can like now each of these are their own data frame. So you can literally, this group is basically data frame. You can pick this group and work with that, and you can like work on this small or subset of your original data frame. So this is how you can work with the groups, and this is why you want to work with the groups. And Python partners basically provide you with this kind of functionality. Now next topic, we're gonna deal with two data frames and how we can merge two data frame. Now, those of you who have already worked or taken the database class might remember this inner join, left join, right join, outer join, and stuff like that. So you can use the same concept here also. Basically, if you see, data frames are basically a table structure, kind of tables. And when you have two tables, you should be able to do this kind of like table operations, which are basically algebra operations, and which are used in SQL a lot, because SQL is structured query language, and the basis of SQLs are tables, and that's all makes sense. So first, let's start with creating these two data frames. This is the left data frame, and this is the right data frame. Now, how we do merge? So basically, the first thing is like you can just do simple cross multiplication, where like left and right, just for each left all the right, for second all the right, third all the right, and you just explore data with so you have 5 records here. So each of these 5 records, there are like another 5 records. So 25 records you end up with. Or normally what we do, we pick the unique ID and then we match the unique ID. So how we do? So we have this two table, and this two table will have some kind of unique ID, or some kind of like ID which will like try to map with each other, and we can use that to merge them. So how we can do that? So we can do something called pd.merge left and right, and then we say that perform the merge operation on ID. So what happens? What it will do? It will look into the ID of left and right, and for what, like it will just, so when you see ID1 here and ID1 here, so okay, my ID is merged, and now whatever records are there, I'm going to append my records with the ID1 because these two record match. And then likewise, so ID2 and ID2 match, so I'm gonna append my records here, the other records here to here, and like complete the whole data. And this two and this two record with this ID2 and ID2 will be merged and give you the final answer. So this is what you get here basically. So you basically perform the merge operation, and the merge was done using this ID of both data frame. and you see this final answer. Now, what if you are trying to do merge on certain column which has missing value? So here, if you see the ID 12345 and ID 12345, they both perfectly match. So it's easy to do one-to-one mapping. That for every one record here, there is one record here, and there is no missing. But let's look at some other data like name, Alex, all start with A, and right, all start with B. And if you see the subject here, subject 1, 2, and the 3 is missing, 4, 5, and 6. So 3 is missing here, and you can see 3 here, and 1, 3, 4, 5, 6. So if you see here, what is missing? So 3 is missing here, and 1 is missing here. So subject IDs, which is have some kind of overlapping where one values are missing from both of them, and other 4 values match here. So what happens if I try to join based on subject ID when there is a mismatch of data or mismatch of values here? So basically, you can do two things. Either if there is a mismatch, just don't add them in my final result. So for whatever 4 things that match, let's just keep those 4 things which are matching in both sides. And whatever is not matching, let's not use that, and let's drop that particular record. That is first thing. Second thing, hey, I think my left is more important than right. So what I'm going to do, I'm going to keep my left, and I'm going to keep all the records of the left, and I'm going to match with the right. And if there is record I have in the left and there is no record in the right, so I'm just going to keep my left record as it is and write null in all the other right side record. So I will be losing this one value in the right, which I don't have in left, but I will keeping all the value in left, and vice versa, that I want to lose value in the left, but I want to keep value in the right. And finally, I want to keep value in the both side, and I want to maintain whenever whenever there's a mismatch. If mismatch is in left, then keep the left empty, and when there's mismatch in right, so keep the right empty. So in that way, basically, you end up with the like superset of all the subject IDs, and whenever there is no matching, you will see the null in likewise columns. So how you can do all these different scenarios? So first is left joint. So in the left joint, basically you keep the left record as say left. So here it's kind of like easy for you to understand, because when I say left, I'm actually naming it left and providing as a first. So when you say how equal to left, it basically keep all the record from the first data frame. And when you say how equal to right, then it keep all the right side of data set, and put the left. So left and right will cover these two cases where I want to keep left all or right all and put the null. And now if you remember inner and outer, so what will happen in inner will only keep the record which are common. So if you see there are 1, 2, and 3, like there out of 5 only 4 records are kept. So when there was a mismatch, it dropped. You can't see 1 and 3 because 1 and 3 were mismatched. One or the other was not existing one of the other. So you can see they are being dropped. And outer is like keep both of them. So as you can see here, this one is also kept and this one is also kept, and basically subject 1 and subject 3 are kept, and whatever is missing are being put as a nan. So this is how we can do the join operation in the terms of alphabet algebra or group theory or maybe SQL. So this is the term join that we use here. This is a join operation. Here we call merge it. So we call merge here, but basically this is the join, other term for the same kind of operations. Okay, now let's get back to the groups again. So this is something like merge operation. So this is the group. If you remember this, we already created this group year-wise already. Now what you can do, so you already had the group. Now you want to pick certain group. I don't know why I didn't like mass match. I changed the order of this whole thing. Anyways, let's continue with the group again. So group.get group. And so basically this will give you, so when you say get group 2014, so whatever group was there that was created for 2014. Let's look back here. So this was the created for 2014. So it will give you the data frame when you say get group.get group, and then going for 2015, you can pass this value. So whatever you say as a group by, so because this is year-wise group, so you can pass the value of those groups here, whatever value that you have in the year here, and based on that you can get the groups. You can get only year-wise because this group was created using year. If this group has been created using team, you could have you could have passed here team and team only, and then get the data frame that were trailered or sorted by the team. And finally, you can apply aggregation operation on particular. So you have these different groups. So this is my group 1, 2, 3, 4, and for each of this group, I pick that in that particular within the group. I pick them point as a column, and then I say aggregate and dot aggregate, and then I pass the aggregation function object here basically. So it gonna, so on each group, each data frame, it gonna pick this particular one column and then apply this function. And let's say you want to see more aggregation, so you can do this also, like on the point I want to do sum, I want to see mean, I want to do standard deviation. So for each group, it will pick the points because we are seeing the point as a column, and then finally aggregation. And here you're only passing the one value here. Now here you are passing the whole like list of functions. So for all each list of functions, you finally see the values here. So with this, we are concluding our Python data frame. So I hope you guys learn all the Python data frame stuffs here. Now let's get back to our original plan and get back to our day 5 materials. So we have 1 hour left. I basically has 3 extra things that I wanted to cover today. One is plot data. Let's get into plot first because it's easy and smaller, and then we will see how much time is remain. So now plotting. We have seen all this, like all the data frame. Now we have all the data. We did all kind of aggregation, summarizing, data massaging, trying to select, random pick, all this, like, we've been working with the data. We've been like using all this operation with the data. But you finally, when you have the answer in your hand, you want to really like create the charts and graph, because people or executives, they're not gonna read your report by looking at the data. They want to see chart. If it's a hockey stick, it's going up, it's going down, it's like shuffling, like this is what they are looking at. Because looking at the number, and it's basically about the pattern. It's hard to recognize the pattern just looking at random number, but it's easy to look at the visual chart and understand what is the pattern is and what is the data is trying to tell you. Giving the raw data will make things much more confusing, complicated. But when you represent the same data in form of charts and graph, and the representation of the data becomes so much clear that you finally know that what you actually want to do with the data, with your final results. So it's very important to finally create all charts and graph to quickly see and look at the data and get feel of the data. How we can do that? Python has a very famous and very, very rich library called matplotlibs. This library is so big that I cannot take like 7-8 hours on just this single thing. But with the time, I'm just going to give you something very minimal. You can always look up and you can try to figure out, whatever you want to do with the matplotlib. Hey, I want to create this kind of chart, and you can find out what you can do. I'm going to cover something very, very basic. So it will make easy for you when you try to look for answer online, and it will make more sense to you when you're trying to do that. So first thing first, how you start with matplotlib. Before plotting any chart, you need to first define where I want to plot the chart, or some kind of like object to work with basically. So what you do, I think irrespective of anything, like you will be writing this line called matplotlib.pyplot as plt. So pyplot is your basically the module that you mainly work with in matplotlibs, and you just import them as plt. Now, okay, so now we know that, okay, this is something we want to work with. Now, how many ways we can actually plot the graph using PLT? This might get confusing when you start looking up online, because everyone prefer different way, because there are multiple ways you can create the graphs. And we're gonna just take an overview, like what are the ways you can actually create the plots. So first, you can just do something of plt.plot x, y, where x and y is just like simple list. And when you provide list x and y, just try to create the a fine linear chart on your x-axis, y-axis, a standard line chart with the data being provided is in x and y. Now, the thing with this is in single image object, you will only have one chart, only have one figure. So when you're using plt.plot, you are actually dealing with only one figure in one picture frame. Now, as you know that there is because I'm saying that there is only, this can only support one, that means there is other way if you want to put multiple charts into single image. So you to do that, you do something called plt.subplot. Now, as it says that you are creating some kind of object that will create multiple subplots. And you can create different kind of space within the single. It will all make sense. Just understand that when you are dealing with one chart, use just plt.plot. And when you're dealing with multiple chart, you actually do something called plt.subplot, and then that will return you some kind of objects, and then you work on each of these objects. So here, if you see, you are just directly accessing plt.plot, and this plot is basically what kind of plot you want to draw, and plot is by default 2D line chart. Here, when you say subplot, it will give you some kind of uh, some kind of a pointer or some kind of object, and it's called axis object. And on each axis, then you can do your plot thing. So something that you are able to do like directly. Plot.subplot will give you like multiple space to play with, and corresponding object that you can point to that certain areas, and then you can do that. So this will create only one plot because you are not providing anything. So technically this and this are same. But when you say subplot 2 comma 2, which will basically in the single image, you have actually four. In the single image you can put four chart, and for all those four chart, now you have like four different pointer that will point to different chart, and then you can manipulate or modify and apply or do things with different chart areas. And third method is something called figure. So figure is basically the bigger of a class, uh, a major class, and these are all like on the hierarchy. This all plot is a subclass of figure. So it will give you the parent class figure, and then you can work with the parent class. You can directly work with the parent class fig, but you won't do it too often. So out of all these three, most of the example you will see online will be using this method too. That let's start with subplot, and then if you want one, if you want more, we can keep adding more. But the idea is you will see method two being used more. This for single one, this for multiple, and this is like really very very custom that you can do here. Very much customization. So let's start with the simple one. So this is x, this is y, just simple x and y numbers, and then you say plt.plot method one, and then you say plt.show. Plt.show will basically actually do the plotting here. So when you do this, you can see this chart x y numbers, and this line chart is being plotted here. So if you see, there's only one figure here, like in the whole image there's only one chart here, and then x and y, and it's just simple x and y bar chart plot. So when I say plot, this is like line chart, line graph. But instead of this plot, I can use something else. Let's say if I want to do the bar, then I can say plot.bar, and it will create the bar chart. And because bar chart is also like x and y, where this is my x, this is y, and based on my y value, my x will have like this many numbers. So this is the bar, this is your bar chart. And then finally you can also do something called histogram. Now as you know, that histogram is basically certain value versus the frequency of the value. So we don't need two lists, we only need one list. And when you say y, it will automatically count the unique values and like unique counts for each number, and then create the histogram for them. So here we are not looking at x, we are just looking at y. And let me create this one first. So if you see here, you can see all like 2, 4, 5, all of them are 1. Let me add like a couple of them, like let me add 2 more. So that means now I have 3 number of 2s, like 2 count of 2 is 3 and everyone else is 1. And now let's do this plot again. So now you can see that 2 is like 3, and then other is 1. So basically frequency count. So that is what histogram is, and that is what we can do here. This is simplest, easiest, and minimalistic way to plot something. When you have x, when you have y, and you can just plot x and y, and then different kind of graph using x and different kind of graph. Now let's get into the second option that I was talking about. So when I was saying that you can create like multiple play area, so this is what I was talking about. Here there is only one image in one area. Now you want to create, in the single image, multiple area, multiple graphs. So you can say plot the subject 2, 2, and this will give you. So because this is 2, 2, so this is 2 and this is 2. So kind of matrix way. So so this is like axis 1, axis 2, and axis 3. You can give any number here, but basically 2 cross 2 will create this four play area, for graph area, and then it will give you the pointer. I mean, you can save this the pointer, and then you can play with each of the pointer individually to modify those data. So here we have like axis 1, 2, 3, 4, axis 1, 2, 3, 4, and we are plotting the same thing here. This is our like regular line plot. This is our bar chart. This is a histogram. This is a scatter plot. And you can like play around. Let's say I want to make my x1 as a scatter plot and x2 4 is the line plot. So I'm just changing the methods and like just like modifying them. What went wrong? Okay, okay. So because it was the kind of chart it was, it has to have the same number of x and y scatter plot, because x and y like 2 dimensions like x and y. So the error occurred because my x and y was not same. I mean, because it's a scatter plot, it is like like x comma y way. So you need to have equal number of x and y. If one is more the other, it will create an error. So that error was due to histogram that we were trying to create. Anyways, so basically you can see that now we've been able to change things. So now this is like very simplistic. Now I want to customize my graph. I want to customize. I wanna write down the title. I want to like change the color. I want to like write something on x-axis, write something on y-axis. I want to like change the range. This is 2 to 8, which is like pre-built. I want to change everything. So how I do all the customization in my single graph. So for that, so let's get back to the customization. And for the purpose of the customization, I'm just gonna recreate the whole thing again. And I'm just picking up the one here. You can pick two also and do the same thing. It will work fine. But just for the purpose of having the large image here, I'm gonna do it like single. Give me a sec. Okay, so now we have this AX, that is our pointer with which we can navigate or customize our graph. First thing is a fixed size. So fixed size basically tell that what is the size I'm going to use here. So when I'm say 15,6, so this is like the dimension. Now I can reduce the dimension and change it and fit it the way I like. So you can change the figure size. Let me like make it too small to make it obvious. So let me just restore it to a bit smaller, will fit well. 10,5. Okay. So I can change the figure size here. Then I can customize. So first thing, like this is just a size of my dimension of my figure that I'm trying to plot here. Second thing is what kind of chart I'm trying to plot. So we had multiple options. We saw like multiple options. There are so many other options out there. I'm just presenting something which is very, very much used and very much common. So scatter plot x comma y. So it's going to plot x comma y. And second thing is I can set the title. So set title, give the title name, set the font size, set the color, and x and y labels. So you can do x and y labels, font size, color, and then you can also set the axis. So when I say ax.axis 1 to 12, so basically it will create the axis 1 to 12. And so first is for x and second is for y. So 1 to 15 is for here, 1 to 15. I can also change, let's say I want to change my range from 1 to 15 to something else, something smaller, let's say 1 to 10. So you can see here 14. And now when I do this, now it's 10. So you can also like make the change and see this point got cut out. Why? Because I have some data point which is like more than 10, but because I'm cutting down my plot, it got cut out. And when I say, let's say 11, now you can see it here in the chart. So the idea is you can kind of like pick up the dimension and pick up the whatever the how much crop you want in your figure that you can set here. And you just be mindful that when you provide this, that your x and y, like the min max, are being covered here, so you don't miss out on data while plotting them. And grid is true, so you can see this background grid, you can keep it false and then it will go away. And this is just very few of the changes. You can do tons of more changes. I'm just setting up the groundwork here that this is something bare minimum, and then you can look for different things. What are you going to do? Google online and search for the like different things that you want to do, and you will find someone telling you what you can do and what you can change and what option you can make change to do that. One very useful thing that I want to showcase here. So if you are working with the Jupyter Notebook, there's this shortcut called Shift and Tab, and which will give you kind of like the method definition that is coming out of subplot. And then you can see that what are the options that you can provide here. And so this is basically doc string. As we say, like these are all the options that you can provide. This is all things that you can pass in your like what it returns and what subplot keyword, and then all these things that you can provide here basically. So if you just want to like interested and want to see what is possible. Now this is all using matplotlib. And your first question is going to be, we are just working with the normal Python data, but most of the time our data will be in Python pandas. Now pandas is something very good thing that Python pandas has some kind of wrapper on top of this matplotlib. So Python panda internally use matplotlib and has created certain methods around matplotlib, and you can use those methods to act directly on your Python panda library. So what we're going to do here, let's import like just the same thing, Python pandas. Titanic dataset is one of the very famous dataset. You can just search online Titanic dataset. This is the dataset which basically tells who survived in that Titanic ship thing, that tragedy. So it's kind of like who died and who survived kind of dataset that you have. Some of you might pick this dataset as your this kind of hello world for data science world. Like if someone who want to build their first data science machine learning model, they will use Titanic dataset to work with that, and you can look up online. This is like hello world dataset for machine learning. Anyways, so we are reading this data and we are saying that Titanic.head. So you can see all these columns here: passenger ID, survival, P class, and stuff like that. We're not going into too much detail, but this is the data that this is the data frame, and this is the data that we have. And now let's pick one thing. So Titanic.info. So this is data frame has something called .info, which tells you all the columns and how many non-nulls values are there and what is the data type of the column. So some kind of descriptive value of the data frame that you have. You can use data frame.info. We haven't used this yet because we are just playing around with data frame, but this is something very frequently data scientists use or data analytics use once they load the data. We'll look into that. So we load the data, and then now finally we are so what we can do is data frame dot column and dot plot. What it will do, so you can pick that one particular column and then you can use dot plot to plot that particular column. And here is the age. So by default, so this is the indexes. I mean the labeling of your like row index. Like by default, it has indexing of like by default 0, 1, 2, 3, 4 index. So those 0, 1, 2, 3, 4 are here, and then these are the values. Like it's the age. So you can see that age could be anywhere between 12.5, 13 to up to probably 80. So this is like a line chart for the age that you see for the each record here. And so basically this is the wrapper, this is the same plot. So because this is the same plot, you can use all those functions that you saw in there up into matplotlib. You can use here because Python pandas kind of like internally support the matplotlib itself. So you can just pick your column itself, and you can work on that. Now you say that what about if I want to like work on multiple data? So you can kind of like, it's not like you just work on a single. When you say like whole data set, it kind of like give you all the data. So it's try to plot each and every data here in the single graph. All the columns are like picked up here, fair, porch, all the different, and they are being plotted here. These are all numerical values. So it just by default to pick all the numerical values. So the idea is when you have multiple, it's not like you can only work with single column, you can work with multiple columns also. And right now for this one, we have picked them. So because it's just plot, and if you remember when you said just plot, you are just working with the one data set. So because of that, in single figure only, everything has been like dropped down and everything is like laid out here in the single image, because you have these multiple columns and you are just calling this plot, which is like designed for the single thing. Anyways, so now let's go into much more customization. Now you will see very much similarity between those two methods, but not everything is 100% same in those two methods. That means there will be some bit of change. Like, hey, in matplotlib, I can just say, like the date, like plot.plt.hist. But here that hist is not there, and hist has to be provided as a kind equal to hist. But then fixed size is same, grid is same, font size is same, and all these things are same. So kind of like some things will be exactly same, but something will be a little bit twisted one or the other way. But you can but the idea is if you see something in matplotlib, you can definitely do something similar. Might be not exactly way, but might be somewhat twisted way into data frame also. So now again the same age. So we are saying histogram because we want to see that how many people are in that particular like histogram, like age 1, 18, 19, 20, whatever age, and how many people are, based on count, how many people were there. So you can see this age range 0 to 80. And this is the count. So because it's the histogram, so in x-axis you see the age, and in the y-axis you see the count. Now if you see here, we have provided title, xlib, ylib, and legend. Legend is basically this thing come here. So you can say, you can set the legend, and this particular thing come here. When you have multiple variable going around here, you want to like have the legend here. So, and location equal to best, it's just like it automatically pick the location, but there are multiple options for your I'm just doing shift tab thing again, and you can see that there are multiple options being provided for location. Let me just show you quickly. uh, where is it? Yes, like this, like upper left, lower right, upper right, and all this thing you can provide. And when you say best, it just pick whatever the best places the legend, the location among the 9 locations so far, and pick whatever is the best kind of thing. So this is something you can do. uh, Count, and so this font size, and that has been customized here, that has been added here. Now very interesting, something called row equal to 45. So what happens sometimes when you're trying to, these are actually the values, and let's say you have some big values, so value will be like kind of overwriting on each other, and like the graph will be very weird. So what you can do is you kind of like rotate the values. So instead of keeping it like straight, you can like kind of like cursive it, and that you can do is using rot. And when you say rot equal to, let's say, 90, uh, so you can see here the whole data are rotated to 90s. So this is like all the customization that you can do with the chart and graph. So I'm telling you here that so many things possible, but you have to look up, and I can't cover each and every functionality here, but just try to give you the overview of all these things. So this is your overview of matplotlib. Now let's get into, so I have some selected topics, but I don't think I will be able to cover it, but I think I want to showcase something which is much more interesting, and then if time permits, otherwise you guys can take it on yourself. Okay, so let's go to Airbnb dataset. So we have this 7 MB Airbnb dataset here. It's a Airbnb New York City dataset, which tells that how many listings are there on Airbnb, what is the cost, and like all the other parameters that we have around here. This is a link to the dataset. You can look up online, and let's get into it. Seaborn is basically libraries for the chart and graph. So one of the thing that you can do with the matplotlib is use Seaborn. So this is something advanced stuff in matplotlib, but you don't need to worry about that too much right now. Uh, and let's get those default things like NumPy, pandas as it is, and Seaborn, and then matplotlib, all these things. So regular import. Now if you see here, this is just I'm trying to print out the file in current directory. So it says that my file is already here in my current directory. Dot means current directory, os.walk, get me root dir files, and then I'm just printing the file name here. So so my file is in current directory, so I can just provide the file name here, because it's my current directory. I can just write the file name. I don't need to provide absolute path here. So pd.read csv, as you know, panda data frame, you can read the csv file directly using pd.read dfe. So this is our data frame. Wait, what happened? Okay, I haven't executed this. Pandas as PD. Okay, so now our data frame has been loaded. Now, how someone start when he has first data set? Either you are data analytics or data scientist. This is how you normally want to work with. So first thing, you load the data, of course, and then you want to take a feel of what data is look like. Sometimes you're going to have data which has like 100 columns and 30 rows, and when you open the CSV file, it will be very hard to understand what is going on. So you first load the data and then try to understand what it looks like. And by default, you start with saying df.head. This is all the systematic way how people do that. So this is more like use case scenario where I'm going to systematically look into data set. Now, why I'm working with this data set? Let's say I have this upcoming weekend when I'm free, I have a holiday. I want to spend my weekend at New York City, and I want to figure out where I can do Airbnb. So because New York is very well connected, I can stay everywhere. I have certain budget in mind that, hey, I don't want to spend too much money, but I also want to maximize my experience. So let me say, like my end goal is to decide where I want to finally, what is the overall expense look like when I want to do Airbnb in New York City, in different region of the New York City, and finally decide on in which area I want to finally start looking for the place, because New York is very huge. There are so many listings there. So so this is my end goal. I want to find that one place where I want to rent my Airbnb, or find the location where I want to rent my Airbnb for my weekend. That is my end goal here. And I have this Airbnb data set which tells me that, hey, these are all the listings of Airbnb in different locations. And let's see what I have here. So first thing is ID. ID is just some random unique ID of Airbnb listing. So this is just random thing, doesn't matter. Name name is basically when you go to website, when you go to Airbnb, and they like some kind of like tagline for their home, like the village of Harlem, New York, like some fancy keyword to present tagline or something kind of title for their listing basically. So that's the name. Host ID. Now this being listed by certain hosts are basically people who are actually renting their Airbnb, renting the property on Airbnb. So this is John. So John, particularly, John owns this property that he is Airbnb. This property is listed in Brookline. So neighborhood group is Brookline, and this is a neighborhood group. So New York is like, if you haven't seen New York, it has like multiple area: Brookline, Manhattan. Uh, if you have watched uh, Marvel's basically Captain America, Steve Rogers, he's from Brookline, New York. He says that I'm from Brookline. So this is the Brookline, New York. Manhattan, of course, everyone has heard that, like Central area, Central Park, Manhattan. And Midtown is like Midtown. Harlem is again one of the famous area in New York City. Anyways, Kingston is like, these are like small neighborhood, like small town, and this is like big part. So let's say Brookline is, let's say this is like Surat and Navsari, and then this is like Varacha, and this is like you know probably Piplo, something like that. So just putting up the analogy here. Longitude, latitude, locations, and then what type of renting is there? Like, is the private room renting? Is the whole apartment renting? Or like, you can have three kind of renting. Basically, you can take a bed, or you can take the whole room, or you can take the whole apartment in, like, let's say two bedroom apartment. How many minimum night you have to stay? So if you want to stay here, how many night you want to spend here? How many reviews it got? Like, how many reviews this particular apartment has from previous viewers? Reviews per month. So this is kind of like average, how many reviews this particular property gets per month. And finally, calculated. So this is something they're already providing us, that this property is listing by this certain host, and this host has other 5 property, and total 6 property he's renting in general or Airbnb. So this the host attached with this property has 5 other property, and total 6 property in general. And availability, so how many days it is available in a year. So 365 means it's always available any day in the year. So all this data I have basically. So now I understand what my data look like, what are all the fields are now. Now let me go one, try to get into the lab. So now let me see how many data I have. So df.shape, as you remember, df.shape give basically row and column. So there are around 50,000 rows and 16 columns. So this is like one of those things. And if you remember, we just did that, df.info. Now, as I know how many records are there, I want to get into the 16 columns. I want to understand what this column look like. So what I mean look like by what are the types of these columns, and basically how many missing values are there. Now I know that there are total 48,895 records. So when I don't see the exact number, then I know that something is not available, or something is missing, or there are null values in my data set. So if you see this record, so id is unique id, so it's always going to be, always id will always exist in everyone. So it basically says that it's integer type, and there is no, and there are this number of not null, which exactly number of records that we have. Now name has somewhat less number of numbers than 95. That means there are some missing here. And it's object, because as we know that object is a string, or string is an object when it comes to NumPy and pandas. Host ID is again like, we have complete data. Host name is missing, so some people are not providing the name, whatever reason, or this might be optional thing. So you can see host names are not there. The property, this group is, it exists, like, so you see that they all exist, and then there are more missing here. Now you see that, like, let's say there are only 16 columns. You can easily see that. What if I have, like, let's say hundreds of columns? I can't, like, go one by one and see all the 100 columns, and like, so there has to be a better way to do that. So we'll look into that. But so this is basically, we are looking at the columns, and we are figuring out what is missing and what is there and what is the type and everything like that. And total memory is like 6 MB is being used, because data is itself is 7 MB. Now df.describe. So info will tell you about the columns, and describe will tell you about, like, kind of descriptive analytics. We have seen this yesterday. So whatever columns which are numeric type, which are of not object type, which are like float or integer, it will try to give us some kind of numerical idea, like count. So count will tell us, like, how many basically records are there. So we have basically full records are there, so we can see all of them. And wherever there will be missing, so here there are some missing, so it tells that, hey, this one has missing, it's not like full number. uh, and then mean, medium, standard deviation. So you can see all these values. So you can, so one thing you can see that minimum renting is 0. So probably some values are missing. That's why I say minimum is 0. And maximum is there is some room which costs fucking $10,000 in for one day. So there is one property which cost $10,000 for one night in this whole data set. There is somewhere something's one place is there. Now this is our quadrant. So 25% of property will come under $69. 50% listing will come under $100, and 75% will come under $175. So this is like really, really extreme values. So if you see here, 75% data will have the prices under 175. If you see quadrant in the bell chart, so you start with 0 and go to maximum, and then 25 is the point. Like I have reached 25% on my x-axis. What is look like my y value? I have reached 50%. I'm halfway in my chart. What looks like? So I can tell that half of my data, this side of the curve, and what value it stands. So I can say that, like, 69 and 106 and 175. So basically the meaning is my values, like 75 values are 179. So this is like very extra. It's not like evenly spread out values. There are some extremes in this data. That is what it's trying to tell me here. So I'm trying to tell you that when you see this data, this is how you understand what is going on in the data. Because when you're looking as a data scientist or data analytics, you're looking at the data, you are trying to understand what it's trying to tell me. What is the story data tell me? The statistics tell me that, although my minimum is 0, maximum is 10,000, but still, my data is, what my data tell me is all my 75% of my records, 75% of my listing are just under $175, nowhere close to $10,000. So there are a lot of skewed data here. And same for the night. So one night, so how many minimum nights? So on an average, people are asking you to stay for 3 days, and mean is 1, maximum is 5, and then there's some random value because it doesn't make sense of you need to like rent the whole thing for like how many years, like probably 4 years renting. They are asking you, hey, you can take this property, but you have to rent. Probably someone is subleasing his own property instead of renting it out, is renting it on Airbnb for 4 years, which is crazy. Anyways, now number of reviews. So you can see number of reviews per month, and then how many hosts. So there's some freaking host who has like 327 properties in Manhattan or in the New York City. There's some guy who has 327 properties in New York City. Like, the single apartment costs probably 100 million or 10 millions, and there are some freaking rich living in the New York City who has so many properties down there. Anyways, but on an average, you can see that most of the people has only one, so minimum one, and like probably like on all your quadrant, you see that everyone is owning one or maximum two. So probably after 50%, you cross 50% of the data, you can find some record which has two listing, and then 327 is probably like other end, because 75% data doesn't has more than two listing per one single host. So this is a story that you can extract from this data, and it tells you what is going on here. So I can set my expectations that, hey, I can expect to pay somewhere around, like, because this is 50 to 75%. So probably within this range, I should be able to rent for a day. It gives me some idea. Probably I need to rent for, there are less chance that I can get something between minimum nights between like 1 to 3. So if I'm planning to pay between 106 to 175, I need to rent it for minimum 3 to 5 days, and stuff like that. Like, you can get this kind of ideas from this data. So this is all tells you that. So now that we understood what data looks like and what data has, we are getting into something called data processing. This is the main game starts here. So data pre-processing has two main phase. First phase is your like dealing with the nulls, and second phase is like adding more data into existing data, or like bringing more data, or like keeping or filtering out data. So basically, first is to deal with null. It has special place in data processing, as it has like it is considered as one of the main processing pipeline on first thing that you do with data processing. Anyways, so let's start with that. So first thing we want to do is we want to figure out what problems lies around here. So with df is null and then doing dot sum. So df dot is null will give you this kind of whole a true false matrix. Remember, df dot is null, it gives you like if it's true, then if it's not null, then true, otherwise false. And then you can do dot sum. So internally, df dot is null will create the table or same data matrix of true false of the size of df. And when you say sum, so it will basically sum your columns, because it's like x is 0, so it will sum your columns. And when it's summing the column, if it's a true, like the true is mapped to 1 and false is mapped to 0. So in the name, there are 16 names missing here basically when you run this whole thing. And when you say host name, 21 host names are missing. And then you say last review and review per month, so there are 10,000 things. So basically there are 4 columns which has to be taken care of, because there are 4 columns which have missing values. Now we know that this is a missing value. Now we say how much missing is there. So if you see name and host name, which is like you have 50,000, close to 50,000 records, and there are only like 10, 15 records are missing. So this is like less than 1% data is missing. So you don't worry too much. Like I can keep with this. I can keep this data and I can replace something, because this is not so many data missing. Now if you see here, there are 10,000 record missing. So this is basically like out of my 50,000 data, 10,000 are missing. So probably my 20% data is missing. So it tells me what I want to do when my 20% data is missing here. So this is the story that we want to like figure out now, what I want to do when 20% data is missing. Because here it's kind of obvious, it's less than 1%. I will just like either drop it or like I'll deal with them, not a big deal. But here I need to decide what exactly I want to do. Do I want to keep this column? And if I want to fill the column, what I will use, because this represents 20% of my data. So if I'm try to fill up the data, then I need to be very thoughtful, because that represents 20% of my data. I can't just throw something random. Here I can throw something random, because it's just less than 1% data. It doesn't make too much difference in the overall big picture. So I can throw anything here, but here I have to be careful, because it's 20% of the data that I'm trying to deal with. Okay, so first thing, this is very generic data, so you don't have to be a domain expert to understand what certain things means. So let's start with review per month. So review per month says that how many reviews are coming per month. And let's say you have listing. So there's last review. Last review says that what was the last review, and then you say review per month. So basically it tells me that I think this particular listing has no review at all. So there are probably 10,000 listing where no one has put any kind of review at all. So there are basically 0 reviews. And because there are 0, because they are null, because there was no data and they didn't care to put 0 as a data, and they just say that, hey, no one has given me any reviews, so I'm gonna keep the null for my value there. So that is why. And that you can kind of logically think that, like, hey, this tell me that what is the review on an average per month, and this tell me what was the last review. So if there is no review per month, there is no last review, right? So basically it kind of says that this makes sense to understand. We can probably like infer that these are the listing where there is no one has done any kind of review yet. So so let's deal with review per month. So review per month is not review. It's not like 1 to 10 what is your review. It is just count. And as you can say, null is 0. I mean, here in this context, we can assume that, hey, no one has put any review, so I can easily say that, hey, my review per month is 0. So what I'm going to do for this particular column, I'm going to say fill NA and 0. And now remember one thing: in place equal to true. Now if you remember the data frame, you remember that it's a mutable unmutable thing. So when I try to alter the data by saying that dot fill NA, it will create the other data frame. It will not change the original data frame. It will create the copy of other data frame. So when I say dot fill NA, the original data frame remains same as it is. But in Python, in the data frame, in the pandas, you can do something called in place equal to true, which will basically force data frame to do the in place changes. So basically you don't have to reassign the whole thing. Anyways, so now let's do that, fill NA. Now let's look at this. So this problem is solved. We are just running the same thing to look for what is empty here. Now last review. Now let's come to last review later, and let's fill something random here. So so name and host name. I don't think I'm going to worry about name and host name, because name and host name are unique numbers, and I'm looking at the columns which are more of like on which I can do descriptive analytics. I can do sum, I can do average, I can do all this kind of stuffs. Name and host name doesn't. It's just name and host name. Like I'm not gonna worry about all those things anyway. So I'm just gonna put some random values there. And so these numbers are dealt with. Now only last thing is remain. Now last review. Now what you want to do? Like, I mean, I think last review doesn't matter for me, because what I worry about is reviews per month, and I think reviews per month already tell me the last review. I mean, imagine that, like I'm more interested in like review per month, like how much review this particular listing is getting versus what was the last review, last single review was there, because I don't care about that basically. So I'm just gonna drop it. And then now let's look at this. So now we have clear data. You can run this command. You can see that, hey, nothing is missing there. So now I'm on the part of like, now I have cleaned my data. Now I can go further. Now, at this point, we have cleaned the data. Now we can actually start understanding data and now start doing actual analytics here. So starting for analytics, we need to have clean data. We have clean data. Let's do analytics. So just again, uh, df.head. So we are just looking at all the columns again. And what we're going to start with. So first I want to understand that how many different unique room types available. So df.room type, which is basically same as df room type. I told you like you can use both of the ways and it will do the same. And this particular column dot unique will give you all the unique value in this particular column. So it will tell that, hey, there are like private room, entire room, shared room. So these are three type of room or listing types available in there. So I can take either private room or entire room or shared room. These three options I have available. That is what data set tell me. So this is one thing that I learned about the data. Now let's look at the value count. So I want to see that, okay, now I know that this three category. Now how much listing are there in these three category? That means how many private rooms are there, how many entire rooms, how many shared rooms are there. So I can do something like room type, which is same as this, and you can do value count. Value count is basically unique value count. So it tells me that there are like almost equal amount of like we have 50,000 data and this is like 20 to 25,000. So basically half of the data are private and half of them are home, and very few, very few are shared room. So I'm not in, I probably won't go for shared room. I will either take private room or I will either take private apartment, because I'm gonna find a lot of deal there, because there's like the most of data rely or lie in this two kind of category, not this kind of category. So this is one more thing I learned, that, or one more thing I understood, that I'm not going to go for shared room because it's too much, and I can go for private and entire room. So now let's go into that. So now I have figured out that I'm going to look into these two places. Now I'm going to understand that what are all the neighborhoods are out there in the New York, and what are listing in different neighborhoods are there. So I can see that there's a Manhattan, there's a Brooklyn, there's a Queens, there's a Bronx, and Staten Island. Now Staten Island has very less listings, so I'm not interested in that. Bronx and Queens. So Bronx is like 1,000, but in Queens there's 5,000. But I think Brooklyn, Manhattan, which is like prime location in general. Brooklyn and Manhattan basically actually, Brooklyn is basically over the bridge. So there are like bridge where which you cross the bridge to go to like from New York to Brooklyn, Brooklyn to New York, and Staten Island you can go with the boat if you have seen New York City. But the idea is like Brooklyn, Manhattan makes sense. I like to stay there. Queens has 5,000 listing. I will consider it, but I know that I'm not going to get a lot of listing there. Bronx and Staten Island, I think they're far and already listing are very less, so I'm not interested. So I have figured out that I'm going to probably look into these three neighborhoods there: Manhattan, Brooklyn, and Queens. Now let's try to do some chart. Let's try to do some plotting here. So if you remember subplot, but we are not providing anything, so we're gonna, although we are using subplot, we're just gonna create one plot, and we are using the matplotlib here. I'm gonna represent here multiple ways to create the charts. So this is basically listing, like just a chart data which tells that, which just compares how many listing are there, kind of histogram kind of thing. So what you're doing here. So first you created this AX, which is like pointing to the figure area, that particular area where you want to play around, and then count plot. So SNS is another Seaborn is a package, something that matplotlib support internally in its huge wide package. But anyways, so using as Seaborn right now, don't get into like just understand the whole idea, and let's not get into technicality. And Seaborn has something called count plot, which is basically histogram. Histogram is count plot. They call it count plot. You can call it histogram if you are using something else. Anyways, so this is something. And in the Seaborn, so you're saying that I'm going to create this kind of like graph plotting object, and I'm going to assign that object to AX. So AX will point to this particular graph object, and then I'm going to like, because AX is attached to subplot, so whatever comes here will come here. And then what I'm going to do, I'm going to pass the particular column that I'm interested in. So I'm interested in df.neighborhood, and then palette equal to mutate, just for like keeping the background white. And then ax.set title. So
as same as you remember, like setting up the title and then plot.so. So using sunbot and count plot, we are able to basically see the plot, which is basically same. This is the numerical data, and this is the graph data, and you can easily say that like visually, instead of looking at the numbers, this make more easy choice that hey, Brookline and Manhattan has so much, like listing. Queens has a bit less, and Staten and Bronx is very less. So I'm probably not going to look into this two. I'll be looking into this two. Manhattan has highest. Probably look into Manhattan. Manhattan is anyway very interesting. Central Park, Friends. If you watch the series, Manhattan, Central Park, Friends. That's in Manhattan. So Queens. So this tell me like about the listing. Now this is another way to do that. Remember data frame. So this is the data frame, DF neighborhood group count. Uh, so here DF neighborhood group count. So we have already created this another sub data frame. So if you see here, this is like group count dot value counts, which will give us another data frame here. So we have already created a sub data frame using main data frame. This is our like second data frame that we created using the actual data frame, which has only one column, and we are using that one column data frame to create the uh, graph. This is where we are using data frames internal plot library. So remember kind equal to bar. Remember from here, like column, and then so the whole thing is already selected, and then you dot plot and then kind and stuff like that. So kind equal to bar, I'm not providing anything else, just plotting the same thing. So this is kind of like, so this was using Sunburn, so that's why you see colorful chart. Here we are using the default matplotlib and data frame backed matplotlib, so you can see just same color, and but the idea is same. One thing you see that it's kind of sorted, so Manhattan is coming as a first because it has highest listing, and then likewise. So all this thing will make you feel like, okay, now I am able to get the picture that Manhattan, probably private or for apartment I'm going to take. Now let's look at the prices, because that is also something concern us. Like I want to look at prices. Now for the prices, what I'm going to do is I'm going to create a data frame, df price count, which will have only df.price. So I'm just going to look at this one particular column, and I'm going to play around with this. Okay, wait, what happened? Blue 400. Let us see. Could not interpret neighborhood group. Okay, neighborhood group is missing. Neighborhood group for dx. So we executed this line, neighborhood group. Okay, I don't know what was. Let's not waste time to figure out debug the code. So what I'm trying to do here is I'm trying to create this data frame where, if you remember, you can filter your data frame using some kind of condition. So I'm filtering. So let's say we remember that our data frame has a maximum 10,000 as our price. So let's like try to like create the data frame, which is like, this is like the whole data actually. I'm filtering, saying that get me all the data because our maximum listing was 10,000. I'm collecting all the data in this data frame. Don't mind the variable name right now. Just we're gonna keep on playing with this for a long time, and then we're gonna create something called violin plot. Violin plot is one of the fanciest thing that you're gonna see, like in long time. I'll show you. So this is the violin plot. Now, what is going on in violin plot? So we are providing this data frame, and then we are saying that what is going to be our x and what is going to be our y. So our x is neighborhood group and our y is price. Okay. So now that we have this, so okay, now I understood what mistake I made. I wanted the full data. I didn't want it just df. So previously it was errored out because I picked only single column, but you actually need the full column. It has to be filtered with price, but it has to be full data frame with all the columns, all the 16 columns. I tried to create only one column. This will only give me one column. I actually need all 16 columns. Anyways, so now I can see the violin plot here. What violin plot is basically, violin plot will tell me what is the distribution look like for the prices. Now, if you see here, all my prices are like kind of like squashed here, and then I see like this long tail here. So which tells me that because of this long tail tells me that, hey, all my values are actually reside here. All data are actually here. They are like squashed off, and these are all the like the extra the outliers, as we call it. They are outliers. They are like really corner cases or very few cases which are like you know getting my distribution too far. But I can see there this is 0 to 2000, so somewhere between, so this might be 1000, and somewhere between 500, I think all my data is live between 0 and 500. And like all these other thing is not interested. So let me get to 500, because I see that all my data is within 500. So now I can see the chart, and I can only see the distribution only for 500. So what is 500? 500 is basically price range. And what this look like, this is the distribution graph of the price for this particular column. So Brookline, so you have this full data set which has a different group, Brookline, Manhattan, Queens, and everything. And all this will also have associated price with them. So what we are trying to plot is get me all the records which says it is a Brookline neighborhood, and get me all the price, and I'm gonna like draw the distribution chart of the prices. So basically tell me that, like, for the Brookline, most of my, so this is like, there are few listing who has like who has a value, who has a cost of listing probably 20, 25, 30, I don't know, going up till probably this will like this the 40 listing. So a lot of records are here. So the more fat this curve is, the more records are here. The more thin the curve is, the less records are here. So imagine that you have a bubble. If you squash the bubble, so that is like your air is squashed out on the longer tail, but then there's a less air in the certain region. So it tells me that this particular region has a lot of records, this particular region has very less record, this has very few, and this has none, close to none records. So in Brookline, I can see that there are a lot of listing here because this is a fat. There are lot of listing here because this is fat, and this particularly look like something around 50 or something. Now, if you look at Manhattan, Manhattan has like kind of like a thin plot. So basically, a lot of listing has been like squashed out. So I don't see so many listing here, but there are quite few listing here. So the distribution of cost and the listing based on cost are more here. So there are like a lot of listing are going towards over the 100 range. Here, most of the listing are below 100. Here you can see that not so many listing are below 100. The listing has been like squashed out and like pushed out, and kind of like a lot of listings are there who are more than 100, which is expected. So you can see that Bronx and Queens, which is like more of a black neighborhood, so it's a low cost neighborhood because of all the reasons. And that's why there are a lot of low cost listing available. But Manhattan is like prime location, so there are very few low cost listing comparatively to other listing. And then you can see there are more listing towards the prime location than other listing. Like probably you can still see a lot of listing here, but here at this particular cost, at the 200 cost, you can't see anything here. Like there's no listing more than 200 here because neighborhood, because of that. So this is what Weinchild tells me, that if I'm trying to look at the Brookline, I'm going to find a lot of listing here. If I'm going to look at Manhattan, I'm not going to a lot of listing here, and my listing could go up. Queens, a lot of listing between range of cost of 0 to 100 or around 50, and probably the same scenario all here. Now we know that we are basically interested in Brookline, Manhattan, because it has maximum listing, and this doesn't have maximum that much listing, so we don't care too much about them. Let's look at these two. One has like a low cost, and one has like high cost, and kind of spread out plot. So more options available here, less options available here, that kind of thing. So this is the violent plot, and now you can go much more deeper. So if you just want to look at under 200, so let's filter all the records which are only about price under 200, and now you can see much more granular graph, and you can see like the costing, and there are a lot of like, you can see here there's some spike at 50, some spike at 100, 150, 200, because people like to keep the cost round, like round figure basically. So because of the round figure, you can see these kind of spikes here anyways. So trying to tell that I'm getting the feel of what my average going to look like. My Manhattan, I could find something like similar number of listings are there between 100 to 50. Most of the listings are here between 50 to 100, and that kind of thing. So now we are fixated on Manhattan because I want to go Manhattan. Why? Because Friends, my favorite TV series anyway. So how are we going to filter the data? So same thing, I'm going to put up this condition inside my data frame, and I'm going to filter my data frame and only pick the record which has a group equal to Manhattan. So this is DF Manhattan that I'm printing here. And if you can see here, I'm getting like, so this filter data frame has around 21 rows records. And then you go to df.price. So this is give you the price, like in this particular record. I have very less time, so I'm gonna try to move fast as much as possible. We're very close. Uh, Now price dot describe. So it's a numerical value, so I can see that that maximum listing was actually in Manhattan, and in the Manhattan area, I should expect to pay between. So there's 95 is like only 25%. I mean, within the 25%, I'm already reaching 95 value as a like cost of single renting, and as I reach 50% of the records, so 50% of the listing are below 150. So in the range of $0 to $150 cost, I can probably find 50% of the 50% of the listing. 75% of the listing will be between this range, and probably 25% of the listing will be 150 and 200 range. So just data which tells me that how much I should expect to pay if I'm trying to find something in Manhattan. I'm happy with that. Now let's try to plot. So again, come back to subplot. Here we are gonna, so we saw the price here. We are concerned about the price, so we're just gonna go much more deeper into price. And now we're gonna plot the price. Now this is the distribution plot of the price, and this is distribution plot, basically telling me that this is the price and how many listings are there at particular price. What I'm trying to do here, subplot, figure, trying to create the data frame with single record, which has only like, I already have data frame, DF Manhattan with like 16 columns. I'm just gonna pick one column, which is gonna be price. So DF1 will only have price for Manhattan. And now in that particular price, I'm gonna again, like, as you saw, that price could be from 0 to 10,000. I just need price between 0 to 250. So I'm again gonna, okay, so this is something I planned before. So this is the price first, and let's look. So this is the price, and if you see the distribution plot here, the same scenario, that because of that 10,000 value, my all my data are here, but my plot is extended. So I'm only interested in like this much, this area, because that is where all my data lies. So I'm gonna filter my data again, and only gonna keep data which is where the cost is less than 250. And then now this is the whole data frame. I only need price. So this is the whole data frame, and then I'm going to pick price. So that is why it's price here. So this is like picking the whole data frame, like filtering the whole data frame, and then picking up the particular column. Now I can see the data between 0 to 250, and I can see the distribution. I can see that, in 100, so cost of 100, I can see the how many percentage of listing is there. Like probably out of the whole data set, this is the percent of listing in 100. The 200, so you can see this spike here. Spike also kind of tell that, hey, 50, 75, 100, 125, 250 is like round figure people like to keep, right? People like to put the round figure there. So that is what I can see here. So I can see 200 as maximum listing, 150, 100. So I can think about anywhere between 100, 125, 150 as 1 day cost for getting Airbnb there. Now we know that Manhattan is, as I told you, like we have picked up the Surat. Now we need to pick the Piplod, or I don't know. I forgot the places. Anyways, so this is all the neighborhood within the Manhattan: Midtown, Harlem, Chinatown, East Village, Financial District, Theater District, Battery Park. Battery Park is like right in front of Statue of Liberty and stuff like that. So Harlem is more like kind of uptown. Hell's Kitchen, Daredevil. Anyone wants Hell's Kitchen is from Daredevil. If you saw watch the show, Chinatown is everywhere. So it is there. So now we know that these are all the unique neighborhood. I want to pick neighborhood now. I have picked the Manhattan. I have seen the cost. Now I want to pick the neighborhood. So what I'm going to do, so let's keep that for a while. Let's come back here. So for each neighborhood, first I'm going to like do the grouping. So what I'm going to group by neighborhood. So when I do group by, remember when you do group by, you basically create this sub data set, and each data set will all record for each of the group. So I have all these like Midtown and Battery Park and Hell's Kitchen and all this area. So it's gonna further break down the whole data set for each of these record. Let me just quickly. I don't have time. Anyways, and then we on that breakdown groups, I'm gonna do the aggregate. I'm gonna see the price, and then this is some little hack that I have done, that I also want to see the count. So I'm going to see mean will give me the mean price of that particular small neighborhood, and then count will tell me how many listings are there basically, and then I'm going to sort by price. So I will see the neighborhood with highest price first and later. So let's just print the whole thing. So I can see that so this host ID is basically host count, and I can see that price wise these are like, you know, like neighborhood.
Attention, please. The signal tone you have just heard indicates a report of an emergency in this building. If your floor evacuation signal sounds after this message, walk to the nearest stairway
I'm closing it
and
down.
leave the floor.
There's some.
While the report is being verified, occupants on other floors should await further instructions.
I need to run down
Attention,
right now.
please. The signal
This is the
tone
result.
you have just
Goodbye.
heard indicates a